Welcome back, friends. In this video, we're going to continue right where we left off. In the last part, we learned how to use Criteria API to build simple and combined queries using dynamic conditions. Now, we'll take it a step further. We'll explore how to add more complex conditions. Alright. On my screen right now, you can see a query with some complex conditions. And guess what? We're going to recreate this exact query using the Criteria API, step by step. Once we finish this, I promise, you'll be confident enough to build any complex condition on your own using Criteria API. So stay with me, let's break it down together. Alright, just take a look at this. When I run this query in dbeaver, it returns exactly 28 records. Alright friends, just forget about the word complex for a moment. Look at my screen, I've underlined each condition in the query one by one, and now it doesn't look that scary, right? If you just break this query down, you'll see, it's not actually complex. It's really just a bunch of simple conditions combined together. One condition is filtering by employee_name, just checking if it matches something. Another one filters by department. Then we've got a condition where age should be greater than 30. There's also a like condition on employee_name, maybe to check if it contains something. And finally, another filter on department. So don't let the overall size of the query scare you. Every condition is simple when you look at it individually. And guess what? In Criteria API, we'll create each of these conditions using predicate, and then just combine them using Criteria Builder. See my screen, I've listed out all the conditions from the SQL query, line by line. Now the best part? We can easily convert each condition into a predicate using Criteria API. So let's break it down. For employee name, we'll create predicate 1. For department, we'll create predicate 2. For age greater than 30, we'll have predicate 3. For the like condition on employee name, that'll be predicate 4. And finally, another department check, that's predicate 5. Alright, now look at this part of the SQL query on my screen. We have a condition on employee_name and a condition on department. These two are joined using the AND operator. So what do we do in Criteria API? Okay, you see on the slide, we have predicate 1 for employee name and predicate 2 for department. Now, to mirror the SQL AND, we simply combine these two predicates using Criteria Builders and method, just like we did in the last video. Easy, right? It's the exact same pattern. Just plug in your predicates and you've got the combined condition predicate 12. Alright, take a look at the slide. We have two more predicates. Predicate 4 for the employee name like condition, and predicate 5 for the extra department filter. See on my screen, these two conditions in the SQL query are joined by OR. To do the exact same thing in Criteria API, we just call the OR method on our Criteria Builder. And just like that, predicate 45 now represents employee name like X or department equal Y. Easy, right? See this part on my screen, our age condition is combined with the previous OR block using and in SQL. So to create that, we just take predicate 3 and combine it with our predicate 45 using Criteria Builder and method, and we get predicate 345 which same condition. Alright, now to get our full query condition, we just take predicate 12 and predicate 345 and join them with one final OR. This predicate 1 2 3 4 5 now represents the entire where clause exactly as in SQL. Hope you now understand how to create any condition using Criteria Builder. Let's switch over to IntelliJ and implement it in code. Alright, let's create a new method, let's call it find. That takes 4 parameters: employee name, department, age, and employee name contain. Okay, since the first 4 lines are exactly the same as our earlier methods, I'm just going to copy and paste them here. Alright, now as we discussed, we'll create our predicates one by one. First, let's build the predicate for employee name. Next, let's create the predicate for department. These two conditions, employee name predicate and department predicate, need to be joined by AND. So we simply call the AND method on our criteria builder and pass both predicates. See my screen. Alright, next up is our age condition. Criteria builder gives us methods like greater than and greater than or equal to. Since we want only those employees older than our age parameter, we'll use greater than. To access the column, use root.getAge. Alright. Now let's handle the employee name contains condition. Just like in SQL we use like. Criteria builder also provides a like method that works the same way. Alright. Now let's quickly create the department filter again. Alright. Now we're going to combine the last two conditions, the employee name contain and the second department predicate 1 filter, using the OR operator just like in SQL. See, Criteria Builder provides an OR method for this purpose. So we just pass both our predicates, one for employee name contains, and the other for department. Next we want to combine the age condition with the one we just created, the one that checks if the name contains a value or the department matches. So we have age greater predicate and name or department predicate. And we want both to be true, so we use the AND method again. This gives us the second half of our full filter. Alright. Now pay attention, this is the final step of our condition building. We've created two main predicate groups. First group, which combines employee name and department. Second group, which includes age some value and name contains something or department matches something. And if you look at the SQL query, these two groups are combined using OR. So, what do? We use criteria builders or method to combine both groups. Perfect. Now that we've built our final predicate condition using criteria builder, the next step is to apply it to our query. Just call the where method of criteria query and pass in our final predicate. Now finally, let's execute the criteria query and fetch the result.
Awesome, the hard part is done.
Now let's quickly expose this through a REST API so we can actually call it and test with different filters from Postman. Let's start the Spring Boot application. Alright, now it's time to hit the API.
Okay, we got the response.
But wait, only 16 records, while the raw SQL returned 28.
Something's off.
I see the mistake. For the contains condition using like, we forgot to add the % wildcards around the search term. Without %, it's not doing a proper partial match, just exact match. Let me fix it now. Let's restart the application. Now, hit the API again with the same parameters. Now we should get the full 28 records as expected. Now, let's open IntelliJ and check the console logs. See here, the generated SQL query is printed. Looks like it's missing some brackets, right? But don't worry. Even though the parentheses aren't explicitly shown, the order of operations, precedence, is correctly maintained by the Criteria API. So the query behaves exactly the same as the original one with brackets. This is because Criteria Builder ensures the logical precedence of and/or operations, so no confusion in results. Next up, we're going to fetch specific columns using Criteria API, not the whole employee object, just the employee_ID and employee_name. Check out the query on my screen right now, you'll see how it selects only those columns. Okay, open IntelliJ. So, earlier we used JPQL to fetch specific columns from the database. Now, we will do the same thing but using Criteria API. Alright friends, now let's create a new method, we'll call it findAll4. Okay, now for selecting all columns, the code we wrote earlier, we can just copy that as is. Because when we want to select specific columns, the changes are actually very small. So let me quickly copy the code for all column selection and paste it here. Alright friends, now let me explain this part in a bit more detail. When we call select method of criteria query class, and pass the root object,
It means
fetch the whole entity, every single column from the employee table. But, what if you don't want all the columns? Maybe you only want employee_ID and employee_name. For this purpose, criteria query provides a handy method called multi-select. With multi-select method, you can pass a list of columns you want to fetch, only those specific fields will be selected in the query result. So instead of fetching the entire employee entity, you can pick and choose exactly what you need, like employee_ID, employee_name, or anything else. Okay, so we want to fetch just employee ID and employee name. We use the root object, which represents our entity in Criteria API, and call the get method for each column. See my screen.
great, it's done.
In the multi-select method, just pass the columns you want by their names. That's it, done. Now, let's execute this criteria query and fetch the results.
Okay.
Now let's call this method from our controller. Alright, let's start the application. Now let's hit the API.
Nice.
Here's our response. Just employee ID and employee name coming back as expected. Alright, now open IntelliJ and check the console logs. Look closely at the generated SQL query.
See this?
The query only includes the columns we selected, employee_ID and employee_name. That's because we used the multi-select method and passed only those two columns. So instead of fetching the entire entity, Criteria API is now fetching just the specific columns we want. Okay, now we're going to sort our results based on a column. Check out my screen. We're going to run the same query, but this time with an order by employee_name ASC. That means we want all our results sorted by employee_name in ascending order, A to Z. Let's see how we can do that using the Criteria API. Copying our existing findAll method, the one we created earlier using Criteria API. Just scroll to that method,
Copy it and paste it.
Now rename this new method to findAll5. Okay friends, first step, we need to create the order by condition. See, Criteria Builder gives us two handy methods, ASC and desc, for ascending and descending order. Both these methods take the column name as input, and we can pass that using the root.get method. Alright, now let's create the order condition by calling the ASC method of Criteria Builder. Pass the column name you want to sort by. Here, it's employee name. This gives us an order object, exactly what we need to apply sorting in Criteria API. See on my screen, Criteria Query provides an order by method which accepts an order object. So just pass the one we created and your results will now be sorted by employee name in ascending order. Alright, now call this new findAll5 method from controller. Let's start the application. And now, hit the API. Nice. We got the response back. Just look at it. Our result is perfectly sorted by employee name in ascending order, exactly as we wanted. Now switch over to IntelliJ with me. Look at the console logs here.
See this part?
It clearly shows order by employee_name in the generated SQL query.
Okay.
Now let's take it one step further. Suppose we want to order by multiple columns, like first by employee name in ascending order, and then by age in descending order. That's super common in real-world applications, right? So how do we do that with Criteria API? Okay, now let's take our existing findAll5 method, copy it, and paste it right below. Rename to findAll6. First, let's create the order object for age. It's exactly the same pattern we used for employee name.
See my screen.
This tells the query to sort by age in descending order.
Simple, right?
Next, we need to pass these order objects into the orderBy method of our criteria query. See on the screen, orderBy can accept multiple order objects in the exact order you want them applied. So, since we want to sort first by employee name ascending, then by age descending.
Okay, it's done.
Now let's expose findAll6 via our REST API. Restart the application. Okay, hit the API.
We've got the response.
Check this out. Our Pankaj Kumar entries are now sorted correctly. First age 45, then 37, then 29, just like we specified. Okay, let's switch back to IntelliJ and check out the console logs.
See this part?
The generated SQL query right here in the log. You'll notice it includes both employee_name and age in the order by clause exactly as we set. Okay, take a look at my screen. Here's the SQL query we want to replicate. It groups employees by department, counts how many there are in each group, and then only returns those departments where the count is greater than our min_count parameter. Alright, since we want to return two values, the department name and the corresponding employee count, let's create a simple DTO class for this. I'm naming it department count. Alright, now let's add the two fields, one for department and one for employee count. Okay, next let's create a new repository method called findDepartmentWithMinEmployees. This method will return a list of department count, that DTO we just built, holding each department name and its employee count. take min count as a parameter. Next, let's create our criteria builder object from the entity manager. Next, we need to create our criteria query object. But remember, we're not returning employee entities this time. We need to return our department count DTO. This tells JPA, hey, build a query that returns department count objects. By specifying department count.class, we're aligning the query's result type with our DTO, so when we select fields and construct new instances, everything matches up perfectly. Okay, next we need to create our root object, but remember, even though our query returns department count DTOs, we're still selecting from the employee entity under the hood. Here, employee.class tells Criteria API which table to query. This root object lets us refer to employee fields, like department, when we build our grouping, count, and having clauses. Alright, for our select clause we need two things.
The department column. And
the count of employees in that department. Okay, now let's build the count part of our query. See here, Criteria Builder provides a method called count, just like SQL's count star. We simply pass our root object to it, because we're counting rows from the employee table. Okay. It returns an object of type expression of long. Okay, now, we want to select multiple columns in our query, in this case, the department and the count of employees in that department. Alright, so see on my screen, the Criteria Builder provides a very handy method called construct. What does it do? Well, it helps us create custom objects, like our department count, directly from the query result. This method takes the return type class, here it's department count.class, a list of values or fields we want to populate in that class. First, we pass the return type, department count.class. Second, we want the department column. And third, we pass the count expression, which we just created for counting employees.
Awesome.
Now that we've created our compound selection object, this is the part that tells Criteria API exactly what we want to fetch. Next step, we just need to pass it to the select method of our criteria query. Next up, if you look at our SQL query, you'll notice we're grouping the results by department. So how do we do that in Criteria API? Super simple. Okay, so see on my screen, the criteria query provides a method called groupBy. This method takes the column or expression that we want to group by. In our case, that's the department field of the employee, because we want to count how many employees are in each department.
That's it.
Now our criteria query will group all employees by department, just like you'd do in SQL with group by department. Alright, now comes an important part, the having condition. So here, we want to check if the count of employees in each department is greater than our input parameter min_count. To do this with Criteria API, first we create a predicate for this condition, basically a filter saying count greater than min_count. And hey, we already discussed how to create predicates earlier, right? Actually, we got some error here because the greater than method expects min_count as a long type, not an int or something else. This happens because our count expression is of type long, so to compare it properly, min_count must also be a long. So, what we need to do is convert our min_count parameter to long. Also, don't forget to update the department count class accordingly. Make sure the employee count field is of type long instead of int. Okay, now we need to apply the having condition in our criteria query. See, criteria query provides a having method, just like SQL's having clause. So here, we pass the predicate we created for the count greater than min_count. This will filter the grouped results to only include departments where employee count is greater than the minimum count we want.
Alright.
Let's quickly recap the steps we followed to build this Criteria API query, step by step. First, we got the criteria builder from the entity manager. Next, we created a criteria query object, but this time, not for employee, but for our custom DTO department count class. Then, we got the root object based on the employee entity, because that's the table we're querying from. After that, we created the count expression to count how many employees are in each department. Next, we selected multiple columns by using criteriabuilder.construct, passing department count class, and then the department field and the count expression. We passed this compound selection into the criteria query .select method. After that, we set the group by on the department column using criteria query.groupBy. Then, we applied the having clause using criteria query.having, and passed our predicate that checks if the count is greater than min_count. Execute this criteria query and get our results. Awesome, the query execution is done. Now let's quickly expose this method via REST API.
See my screen.
Now let's start the application.
Hit the API. Awesome.
See the response on the screen, it's working perfectly.
We got developer 25 employees, HR 17 employees, QA 12 employees. Alright,
Let's hit the API again, but this time with min count 13.
see that?
QA department is filtered out now, because it had only 12 employees, and we set min count 13.
Check the console logs.
See the generated SQL?
It includes group by department and having.
Exactly what we wanted. Okay friends, now here's something cool I want to show you. Till now, we've been using criteria builder.construct to map our query result directly into our custom department count class, which is awesome when you know the exact shape of your result. But remember, way back in the earlier part of this video, we used something called multi-select to select specific columns manually, right? Let's quickly switch to that approach to make it even more clear. See my screen, here we use multi-select and simply pass what columns we want in the result, in our case, department and the count expression for employee count. This tells Criteria API, hey, fetch me these two fields. Super simple and clean. Okay, now let's start the application. Now, let's hit the API. See, we got the proper response from the API, just like we wanted. Now, let's switch to IntelliJ and check the console logs. Here, you can see the exact SQL query generated by the Criteria API is running again. See here, in the SQL query printed on the console, you'll notice a 1 appearing. Actually, this 1 represents the first selected column in the result set. In SQL, when we select multiple columns, sometimes the columns are referenced by their position like column 1, column 2, and so on. So here, that 1 is just telling us it's selecting the first column, in our case, the department name. Alright friends, we'll end this video here because the Criteria Builder API has so many methods, we can't cover them all in one go. But after watching this video, I hope you feel confident to write any type of query using the Criteria API on your own.
Quick summary.
We learned how to build dynamic queries step by step using Criteria Builder, Criteria Query, and Root. We covered filtering, sorting, selecting specific columns, grouping, having clauses, and more. Thank you so much for watching. If you liked this video, don't forget to subscribe and hit the notification bell so you don't miss upcoming tutorials.